All right, 5.3, adding and subtracting rational expressions. So we've been talking rational expressions, and this is really where we are going to look for, can anything on the top reduce? Can anything on the bottom reduce? What can we cancel out, whether it's a group or not a group? But now when you start adding and subtracting, we end up with kind of this whole different mode that we have to set up first. So let's talk the concept. If I gave you 1/2 plus 1/4, and we needed to get these to be added together, the concept of adding is we need the denominators to be the same. So over here on the left, we can multiply by 2, both on the top and the bottom, because in essence, 2 divided by 2 is 1. So I'm multiplying 1/2 by 1, which when you multiply anything by 1, you don't actually change the number, right? You change the appearance of the number. So here's what happens now is when I multiply the top together, I get 2 divided by, multiply the bottom together, you get 4. And we'll just bring this guy down, plus 1/4. Okay, now that the denominators are the same, it gives us the right to add the tops. So now we get 3/4. So 1/2 plus 1/4 equals 3/4. But the idea here is the denominators have to be the same, and so I might have to do some work to get them to be the same. We're going to use this exact same concept down here, okay? But before I even do that, let me give you an easier one to work with. Let's say it's 1/x minus, I am doing minus there. Let's go 3/4. Okay, so let's look real quickly. Denominators are not the same. In order to subtract, they have to be the same. So what is missing in this that this has, and then we'll do vice versa. Well, I'm going to need to multiply this by 4, but if you multiply the top by 4, the bottom by 4, you have to multiply the top by 4 because we've got to multiply the entire part by 1. Okay, and then what's missing on the other side? Well, it's going to need an x, both on the top and on the bottom. Okay, now let's work out the top. So 4 times 1 is 4 over, well, let's put those together, 4x, minus, let's put the tops together, 3 times x is 3x over this 4x. Okay, now that the base, or sorry, now the denominators are the same, we are allowed to subtract. So we are literally going to do this. We're going to go top 4 minus 3x over 4x, right? Because now it's just basically crunching the bottom together all as one. Now we would always try to now like see, does this factor on the top? If it factors something out, we're going to see since this is outside of the group and this is all inside of a group, there's nothing that can be canceled. That's what we were doing last section. So we would literally leave it as 4 minus 3x over 4x. That's the best we can do right there by adding or subtracting. Okay, so let's try the same idea. Let's make it more complex. Ready? Here we go. Let's look at this one, number 2 right here. Okay, first idea is what I look at since, okay, we're adding, not multiplying, because multiplying is totally a different level. Multiplying, we can do anything with the top with anything on the bottom, but when we're adding, we need to check denominators. All right, check the denominators. 4x minus 1 here, 4x minus 1. Oh, awesome. Since they are the same, we literally are just going to write this as one giant function. So it's going to be 2x minus 3 plus 3x plus 4, that group, all over, crunch the bottom together, the group 4x minus 1. Okay, let's condense the top a little bit. Since we're just adding, we're going to go 2x plus 3x, so we're going to get 5x. Then we got negative 3 plus a 4, so that's going to give me a positive 1, all over 4x minus 1. All right, does the top simplify down, factor out? Does the top factor out? No. Does the bottom have any factoring out? No. Since this is its own group, this is its own group, you can't cancel the groups unless they're exactly the same. This would be it. All right, let's try a different one. I do like this one because it is subtraction, so we want to talk about the difference in subtraction. So here we go, bottom denominator 4x plus 5. 4x plus 5, great. Denominators are the same. What does that give us the right to do? Put the tops together. 3x minus 4 minus, check this out, 5x plus 3. Now this is a little tricky because it's minus the entire group, which means I am going to have to distribute that here in just a moment. 4x plus 5 on the bottom, right? Once the denominators are the same, you just write it once. So we're going to get 3x minus 4 minus 5x minus 3 over 4x plus 5. All right, let's keep going. Now we can combine like terms. 3x, negative 5x, that's negative 2x, negative 4, negative 3, that's negative 7 over 4x plus 5. Does the top group factor? Does the bottom group factor? The answer is no and no. Since those groups are definitely different, that's the best we can do right there. All right, let's try one more here. Okay, again, denominators are the same. Awesome. Minus sign. So keep in mind the group, right? So 4x minus 3 minus the group 4x plus 3. And then that's all over the single thing now since those denominators were the same. All right, let's distribute here. So we're going to get 4x minus 3 minus 4x minus 3 over 2x minus 5. Let's combine like terms. 4x minus 4x. Oh, those go away. Negative 3, that's going to be negative 6 over 2x minus 5. That's definitely outside a group. This group right here has nothing that factors out. Best we can do right there. All right, so when those denominators are the same, it's pretty straightforward. What happens when they are not the same? Oh, like this one here. Well, here's what we're going to have to do. This group x plus 6, this group 2x minus 1, nothing factors, so I'm not going to be able to get those to look the same at all. So what are we going to have to do over here? We're going to have to go 2x minus 1 on the bottom, but whatever you do on the bottom, you're going to have to do on the top. So now we got those groups. Over here, we got x plus 6 on the bottom, x plus 6 on the top. So now check the bottoms. Now the bottoms will be the same. But the tops, oh, we're going to have to do a little bit of work. All right, so we're going to get 6x squared minus 4x. Now check this out. I'm doing FOIL or double distribute. It would be another way to say it here on the top. Minus 3x plus 2. Okay, so that's all on the top. And I'm just going to go and carry the plus over. And I am going to double distribute or FOIL here as well. So it's going to be 2x squared plus 12x minus 3x minus 18. So you see how all that is there, and now we're over the group 2x minus 1, x plus 6. And I'm not going to actually multiply those two numbers together just yet, because at the end I'm going to refactor the top. So let's do the top. Let's combine like terms. 6x squared plus 2x squared. So that's going to give me 8x squared. That takes care of my squared terms. Minus 4x, minus 3x, that's minus 7x. Let's go minus 3x, that's minus 10x. Plus 12x, that's going to be plus 2x, right, all together. So put all those x terms together. Positive 2, negative 18, that is a negative 16. All over the group 2x minus 1 times the group x plus 6. Okay, oh, looks like the top is going to factor. So if it factors, I need to try it. Greatest common factor, 8, 2, 16. It looks like we have a greatest common factor of a 2 in there. So I'm going to pull out a 2. That's going to give me 4x squared plus x minus 8. Okay, so that's what that's going to look like now. Oops, on the top, let's go 2x minus 1, group x plus 6. Let's think about factoring this. So 4x squared plus x minus 8. I like my slide and divide technique, so slide it back here. I'm going to go x squared plus x minus 32. I want to try to find, are there two things that multiply 32, add to 1? Boy, 8 and 4. That's about it, right? 8 and 4. We could do 16 and 2. That doesn't help us out any. Is it divided by 6? No, I don't think this factors, guys. So I think we're there. So we're stuck there. It doesn't factor. This is outside of a group. This group doesn't match either of these groups. Nothing comes out of either of those groups. That's it, guys. That's the best we can do right there. All right. So we can do this over and over and over again. So let's try this one here. All right. So again, denominators are not the same. But before I start like just throwing things together, let's look at the denominator and say, do they factor down? Because maybe something is going to help us out. And actually, matter of fact, this side does factor down. So look at this. I could pull a 3, that's the greatest common factor out of this, and I'm going to get 4. Oh, no. Let's try again. I can pull a 4 out of this, and I'm going to get 3x plus 1. So instead of writing it like this, I'm going to write it as the 4 times 3x minus 1, or plus 1. So what does this one have, and what does this one have? Well, this has the group 3x plus 1, so this has, the left side has the group 3x plus 1, but it has an additional 4 to it. And that's the only difference. So let's just multiply this by 4. So multiply the top of the group by 4. Okay, so what does that mean to us? All right, let's do it again. So let's put this group 4x minus 5 plus, I'm going to distribute this 4 across before I write it, right? So because I had to multiply that little side by 4. So plus 12x minus 4. And notice I didn't put parentheses because it's a plus sign here, so I don't have to worry about distributing a plus sign. It's not going to change anything. So then on the bottom, now that both bottoms are the same, we just rewrite it. So it looks like that. Combine like terms on the top. No, I should have pulled the plus in there. So we got 16x minus 9 over 4, 3x plus 1. Anything factor out of 16x and 9 is not an x squared, so it doesn't factor down that way. 16 and 9 don't have any common factors. That's the best we got. All right. Okay, let's do this one. Right, but notice all of this that we're doing here, right? It's just this idea of trying to get those denominators to be the same. Right now, the denominators are not the same. But let's see if this factors down. Check this out. The first one, that does factor. That is an x plus 3, x minus 3. So instead of writing x squared minus 9, let's write it in its factored form. Why? Because then I can see that 2 of them match up. And so the right side is just missing the group x minus 3. So we'll multiply the top and the bottom of that side by x minus 3. Okay, let's write it. 3x minus 4 plus, I'm going to go ahead and FOIL this out. All right, so we're going to go 2x squared. Then I'm going to go minus x. Come back, I'm going to grab the negative 3. Negative 6x. Negative 3 times negative 1 is a positive 3. All over the group x plus 3, x minus 3. Okay, let's combine like terms. I see only that x squared term, so we're going to go 2x squared. Let's see my x terms. 3x minus x, well, that's 2x minus 6x, that's negative 4x. 3 minus 4 minus 1. All over x plus 3, x minus 3. All right, so there we kind of have it nice and condensed, but what do we need to do? We need to see, does the top factor? So 2x squared minus 4x minus 1, I am going to slide and divide. X squared minus 4x minus 2, are there two things that multiply to negative 2 and add to a negative 4? I believe the answer to that is going to be no, right? Negative 2 and 1 is probably the best I can do. This does not factor any. We're going to leave it like this. It's good to go. All right, so you're kind of seeing how this thing works. So let's break this one down. One last one to kind of work with here. So we're going to have x plus 2 on the top. But so this one right here, let's see, does this factor down any? X plus 3 and x plus 1. So I'm going to write it in its factored form so I can see that they share a group of x plus 3. This is missing the group x plus 1, x plus 1. Okay. So now that I know that, let's rewrite it. Take that x plus 2, didn't have to do anything to that side. Ooh, there's a minus, so I'm going to keep this as a minus, and now I'm going to throw everything into a group for a moment. So I have FOIL, so I'm going to go x squared plus x plus x plus 1 all over the groups, right? And once we get those groups together, remember, just write it once on the bottom. All right, but now that minus sign was super important because it's got to go across here. X plus 2 minus x squared minus x minus 1 all over x plus 3, x plus 1. Okay, so here we are. All right, let's combine like terms. Let's see, let's write x squared first, so negative x squared. And then let's find the x's. A positive x minus an x, those cancel each other out, so I just have another negative x there. Positive 2, negative 1, that is a positive 1 over x plus 3, x plus 1. Okay, here we go, factor time. I will tell you this, if you're trying to factor, then we're going to need to rewrite this. Pull that negative back out, x squared plus x minus 1. And then we got x plus 3, x minus, plus 1. All right, let's see if we can find two things that multiply to a negative 1, but also add to a positive 1. Well, negative 1 and 1 are the best that I can do to get a negative 1. None of those add to a positive 1. So this thing is not factorable, so technically we could just leave it like this, or we could leave it like this. Both of those work. All right, so that's adding and subtracting. Think common denominators. We got to get it there, then reduce it down, then see if they factor, and then see if things cancel, right? So it's a little more work than what we've been doing. Okay, and then let's talk one more time about this. So when you see this, a lot of times we see it's a fraction divided by a fraction. Right? Fraction divided by a fraction, just like we did when we talked multiplying and dividing, we don't like to divide by a fraction. Instead, we multiply by the reciprocal. So take the top and write it, 2x minus 3 over x minus 2. Instead of dividing, we are going to multiply by the bottom reciprocal. So the bottom is here. Remember, reciprocal means flop it. So put the bottom on the top, put the top on the bottom, 4x minus 3. Okay, so now it looks just like this, okay? Now, before I just go and multiply things together, let me see if things factor. Well, check this out, x minus 2, x plus 2, right? So this, let me write it in its factored form. Anything on the top is eligible to be canceled with anything on the bottom because we are multiplying, okay? So x minus 2 group and the x minus 2 group go away. That's all I see. So then I got 2x minus 3. On the top, I still got a group of x plus 2, and on the bottom, I got the group 4x minus 3. This would be it right here, and we can leave it in its factored form to do that. So I want you to think about this style of problem, right? Being able to do that there. And so the last thing that we need to talk about real quick is domains, right? Domains are going to be like, what value of x would the expression be undefined, right? So what, remember, like we talked in domain, what becomes the problem? Well, if the bottom equals 0, we got problems. So set the bottom, literally the bottom, equal to 0, and you start solving. 2x equals 5, add 5 to both sides, divided by 2, x equals 5 halves. So when x equals 5 halves, it's undefined. So what we would say is the domain is all reals except when x is equal to 5 halves. So it can be any value we want except for 5 halves. What about this one here? What's the only one that's going to give us fits? Well, it's going to be whenever 4x plus 5, that group equals 0, because when that group equals 0, we're in a bad place. So subtract 5 from both sides, divide by 4, we got it right here. So it is undefined at x equals negative 5/4, right? So that works there. We could do that with any one of these right here. Where is this undefined? Well, it's whenever these groups are going to equal 0, because when those groups equal 0, we have problems. So here, so when x is equal to -3, we're going to end up with a problem. And when x is equal to 3. So it's undefined here. So that means it works for every value except for -3 and +3, because those would create zeros on the bottom of a fraction, zeros on the bottom of a fraction are bad.